All right, guys, today we got arc length, central angles, and angular speed. Haven't decided for sure about the angular speed. We may wait and do that in class tomorrow. We may just concentrate this video on the arc length and central angles. Talked about this yesterday a little bit. I need to make sure you drill this in your head what a radian is. A radian measure of a rotation is the ratio or fraction of the distance, s, traveled by the point, which is the arc length, by a point at a radius r from the center of rotation to the length of the radius. So basically what it's saying is the radian measure of a rotation around a circle is the distance traveled by that point, which is s, the arc length, over the radius, which is r. When we're using this formula, theta equals s over r, we must be in radians. So when you see that s over r or theta equals s over r, we're in radians automatically. And the arc length and r must be in the same unit. You know, the arc length is in inches, the radius is in inches, arc length is in centimeters, radius is in centimeters, whatever the case may be, they must be in the same unit. If they're not, we have to fix that and change them to the same unit. And you may have to do a little bit of that in our assignment today. So that means arc length. If we're looking for just arc length, there's our formula. Arc length is radius times theta, but remember the arc length and radius has to be in the same unit of measure. Okay, a couple problems here. Find the measure of rotation in radians when a point 2 meters from the center of rotation travels 4 meters. So what's happening here is it's asking us for the measure of rotation, which is theta, which is really the angle. Remember, theta is the arc length over the radius. And here they're both in meters, so we're in good shape here. The radius is, the arc length that traveled 4, the radius is 2 meters, they're both 2, so we would just get 2. And our answer, our theta is understood to be in radians because we did s over r. You could put radians, but it's kind of understood that that's the case. That's simple, all right? Look at another one here. This one's kind of going the other way. Find the length of an arc, which is s, of a circle of radius 5 associated with an angle, that's supposed to say pi over 3 radians. So here's what we know. We know that theta is arc length over radius, which in turn means that if we want our arc length, it's r times theta. Now what I did there is multiply both sides by r, and I know both of those things, so the radius is 5, the arc length is pi over 3, and so if I multiply those, I would get 5 pi over 3, and if I punch all that in my calculator, I would get about 5.24 centimeters. That's how big that arc is if it travels 5 pi over 3 radians. Now, I'm going to go ahead and show you one thing on linear speed, just to give you a heads up for class tomorrow. I think I'm going to wait for most of it for class, but let me give you a little bit of heads up for your notes here. Linear speed is just basically the distance traveled per unit of time. That's what we think of as speed. What we do is we take the distance divided by the time. That gives you your speed every time. That's how, even if you go on vacation or whatever, that's how you calculate your speed. Distance you travel divided by the time you traveled. Now in this case, s is arc length, so we're talking about the distance in a rotation, but still linear speed is that way. Angular speed, the amount of rotation per unit of time, is theta over t. And that symbol right there is actually omega. It's not really a W. It kind of looks like a W, but it's actually the Greek letter omega. And when we talk about angular speed, you're talking about things such as this. You know, the speed of a bicycle wheels as it makes 150 revolutions per minute. The angular speed of the Earth is 2 pi radians per day because it goes around the circle 1 time per day. So the angular speed of the Earth is 2 pi radians per day. That's what angular speed means. It's going in a circular pattern. A linear speed going in a linear pattern. All right, I think we'll stop right there and work on the linear and angular speed tomorrow in class. I think it'll be more clear with me helping you than it will be on a video, so we'll save that for tomorrow. But make sure you have the other stuff that we did on the first 2 or 3 slides, the measure of an arc and also the central angle measure. So hopefully it wasn't too bad. See you tomorrow.